Whenever you're asked to calculate the cosecant, the secant, the cotangent, recall that those are reciprocal functions of sine, cosine, and tangent. So here when it asks us to find the inverse cosecant of 2, I'm going to just rewrite this as the inverse sine of the reciprocal of that ratio, which is 1/2. And the inverse sine of 1/2 now allows me to draw my partial unit circle I can eliminate quadrant 2 because the ratio is positive. Ratios that are positive will occur in quadrant 1 for the inverse sine. And then where is the y value equal to 1/2? Well, that's going to happen at a pi over 6 angle. And the pi over 6 angle in quadrant 1 is indeed pi over 6. So therefore, the inverse cosecant of 2 is equal to pi over 6. Okay, let's try a trickier one, the inverse sine of the sine of pi over 7. So remember, the sine of pi over 7 is going to be a ratio. I'm going to put that ratio into the function of the inverse sine, and that is going to give me an angle. Well, pi over 7, that's not a unit circle angle. So let me draw a picture here. Pi over 7, it is in quadrant 1, and it's close to pi over 6. Not quite pi over 6, but it's pi over 6. I'm sure it has an x value and a y value. So whatever that y value is, that's going to be the ratio. So when I put that y value in, I'm going to get out the same exact angle. Let me show you in a table of values. So you have the sine of theta. Okay, this is your traditional function, your trig function, where you put angles in and you get out some specific number. So you're going to get out a specific value. Remember, on the inverse functions, your inputs and outputs are reversed. So when you take that specific value, which is this y value, we'll call it y, right? So if you put that specific y value in, what do you get out? So this is your specific value that we just called y. You're going to get out pi over 7. So that's where we are right here. Here's your inverse sine of theta, right? Of theta. Sorry, that's not supposed to be theta. Inverse sine of your ratio. Inverse sine of your ratio, because you put your ratios in. Ratios. And you're going to get out your theta. So your inverse sine of your ratio, that specific number, that specific value, that's going to give you that pi over 7 out. I meant well with the tables. Let me just show you here, your x and y, your input and output, right? You still have an input and an output, but this is your function, f of x. This is your inverse function. You're going to put in pi over 7, and you're going to get out some value. We can call the value v. Then you're going to put that v into the inverse, and you're going to get out pi over 7. And that's exactly what we did here. We used this placeholder of v because it doesn't really matter what v is. It doesn't matter what that specific value is, because ultimately we're going to just get this value out. It's a little tricky. We do have work to do though, because you can't just assume. So let's think about this. We've got inverse sine of the sine of 5 pi over 4. So sine of 5 pi over 4, that's a ratio, right? You put a ratio into the inverse and you're going to get an angle. So the sine of 5 pi over 4, let's draw a picture of that. 5 pi over 4 is this angle right here. And it's -1 over the square root of 2. negative 1 over the square root of 2 is the ordered pair. Sine of 5 pi over 4 is the y value. So now I have the inverse sine of negative 1 over the square root of 2. This one's important because this is outside of our inverse sine partial unit circle. We need an angle in quadrant 1 or 4. And it doesn't look like a 4, does it? So we need an angle in quadrant 1 or 4. It's going to be one or the other, not whichever one we choose. So this is where we have to say, okay, so now I need that pi over 4 angle, but it needs to be in quadrant 4. And I can't go the long way to get there. I have to go the short way. So this is negative pi over 4. So our angle is negative pi over 4. 7 pi over 4 does not work. 5 pi over 4 does not work. 3 pi over 4 does not work. Positive pi over 4 doesn't work. There's only one answer, and it's negative pi over 4. And again, these partial unit circles will help you determine what your final arc sine or inverse sine function, what that angle is, and if it's correct. Okay, cosine of the inverse sine of square root of 3 over 2. So think about this. What is this? What's the inverse sine of the square root of 3 over 2? Is it a ratio or is it an angle? This is an angle, some angle theta, and the cosine of an angle is a ratio. So can we determine what that angle is? We absolutely can determine that angle. The sine function has a square root of 3 over 2 in the y value, and that's a pi over 3 angle. The inverse sine is this partial unit circle from negative pi over 2 to positive pi over 2. Because the ratio is positive, we're going to be in quadrant 1, so we're talking about exactly pi over 3. What is the cosine of pi over 3? The cosine of pi over 3 is positive 1/2. Knowing your ordered pairs makes a difference. If you've had to press pause during these problems and then look at your unit circle, that's a very good thing. That's a good thing. If you haven't had to look at your unit circle and you've been following me, that's also equally good because you already know your unit circle. If you don't know your unit circle, study it. If you're using your unit circle and you're hanging with me, maybe pressing pause, looking it up, that's a good sign. If you're just watching these videos, you're not really getting where these values are coming from, go back, rewatch them, and really utilize that unit circle and make sure you're understanding where all these values are coming from. Once you start seeing them on the unit circle, you'll get more comfortable with it. But quite honestly, memorizing that unit circle is the key. It is the key. Okay, inverse tangent, we've got 2 more quick ones to do. Inverse tangent of cosine of 5 pi over 3. Try and do these 2 on your own and then come back and check your answer with me. Okay, here I got the cosine of 5 pi over 3 is positive 1/2. And the inverse tangent of 1/2 had to go into my calculator. And if we're talking about radians, which we should, why? Because the angle that was given was in radians. The inverse tangent of 1/2 is approximately, you've maybe had to press pause a couple times now, 0.5 radians, rounded to the nearest tenth. But if we go out a little bit further, 0.46, 0.464. If you go out 3 decimal places. So that will tell you if you've got the right answer. Okay, how about this next one? Inverse cosine of -1/2. Well, this is an angle. In quadrant 2, because I have a negative ratio, and it's going to be the pi over 3 angle in quadrant 2, so 2 pi over 3. What's the tangent of 2 pi over 3? Well, let me write the ordered pair here, because tangent is y over x, so it's negative square root of 3 over 1, which is just negative square root of 3. Don't forget that negative.